Hi guys, so today we're going to be learning about ellipses. Before we get started with our example problems, let's take a look at the textbook in regards to what an ellipse is and some of its key features. Okay. So what an ellipse is, it's the set of all points in a plane so that the sum of the distance from two fixed points is constant. Okay. These two fixed points are known as the foci of the ellipse. So an example is this. Okay? Your foci is -5, 0, and 5, 0. You pick any point here, the distance from that point to here and here, the sum of it would be the same. So this plus this would be equal if I chose this point here and added the sum of the distances. Or if I chose this point here, this to this, okay, it would still be equal. Okay? So here you can use the distance formula and the definition of an ellipse to find the equation of this ellipse here. Okay. We're not going to go into quite that much detail for that. Okay. There are several main characteristics of an ellipse. Okay? Every ellipse has two axes of symmetry. Okay? The points at which the ellipse intersects its axis of symmetry determine two segments with endpoints on the ellipse called the major axis and the minor axis. Okay, the major axis is called the major axis because it's longer, right? So if this is your ellipse, this would be the major axis, and then this would be the minor axis because it's shorter. Okay, they intersect at the center. Okay. And the foci of your ellipse is always going to be on your major axis. Okay, so since this is the major axis, note that the foci are on here. Okay. If you study the ellipse here on the right, again, the sum of the distance from the foci to any point on the ellipse is the same as the length of the major axis, or 2a units long. And the distance from the center to either focus is c units long. Okay? And so by the Pythagorean theorem, we get the formula for it: c squared equals a squared minus b squared. Okay? So one thing that's important to realize, standard form of an ellipse is this. Okay? The difference, A is going to be the bigger one, right? So note that length of major axis is 2a units long. Okay? The only difference is if it's horizontal or if it's vertical. Okay? If it's horizontal, the A will be under X. If it's vertical, the A will be under Y. Okay? Okay. And so note also, since then, if the A is under X, the major axis will be this way. Okay? And so it will affect the X values of your foci. Right? Okay. If it's the other way, it's this way, okay, right, then here is your major axis and your foci will be on it, and here's your center, so it will affect the Y value of your foci, which is why you see that here. Okay? So quite easy to graph. It's center, and then to get your these four main points here, you'll just add A or subtract A, add B, subtract B, okay? And then your foci would be to add C, subtract C. Okay? So now, with that in mind, let's get started with our example 1. Okay. So here, it wants to write an equation for the graph here. Okay. So note here that this is a vertical ellipse. Okay? So what that means is that a square is going to be under Y. Okay? Because it's this way. Okay? This gives you A. Right? So note that our center here, so in between, right, between 0, 3, 0, negative 3, between 0, 6, 0, negative 6 is your center. Right? So your center is at 0, 0. Either by looking at it or finding it using the midpoint formula. Okay. This gives you A, okay, because it's centered to this vertex point here. Okay. And so then this is 6 away. So A here is 6. Okay. B, I don't know what it is, although if I were given and I could count it, we kind of can count it now, but technically since they didn't write it, we're going to pretend we don't know it. Okay. And then the other point I have is C. Okay, so C is center to foci. So here this is a distance of 3. So C equals 3. Okay. To get B, it's going to be C squared. Instead of A squared plus B squared, it's going to be A squared minus B squared. Okay. So then it'll be 3 squared equals 6 squared minus whatever B squared is. 3 squared is 9, 6 squared is 36 minus B squared. Okay. I'm going to subtract 36 on both sides. So 9 minus 36 is negative 27. Huh? Right. And then get rid of the negative by multiplying negative on both sides. 27 equals B squared. And since in the equation I don't actually need B, it'd be useful later to graph it, to find it. Okay, I'm good with that. So now I have B squared, so x squared over 27 plus y squared over, since A is 6, 6 squared will be 36, and then equals 1. Okay, so here is my equation of a ellipse. Okay, if I were to graph it and find this point, you would note that this is square root of 27 comma 0, and this would be negative square root of 27 comma 0. Right, and square root of 27 is pretty close to 5, right? Close to square root of 25, so that's why you can see it looks pretty close there. There we go. The way the book writes it is they write A first. Okay, it's up to you. Okay, it's the same thing because of the commutative property of addition. Okay, so why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten x squared over 25 plus y squared over 4 equals 1. Okay, and here's your explanation. So since the major axis here, I saw that it changes the x values, I know that A is going to be under x squared. Okay? And so I know it's going to be facing this way. Okay? The endpoints of the major axis, that's here, negative 5, 0, 5, 0. This will give me A. Okay, minor axis is this one here, so 0, negative 2, 0, 2. This would give me B. Okay. The center would be either the middle of these endpoints or the middle of these endpoints. Either way, it will be the same. It's at 0, 0. Okay. And then so from 0, 0 to 5, 0, it's a change of 5. So A is 5. From 0, 0 to 0, 2 or 0, negative 2, the B is 2. Okay. In this case, I don't need to worry about the foci unless I was graphing it. Okay. And so then that's how I get this. Right, based on how it's oriented, what changes, okay, based on the major axis or minor axis, that tells me which letter it goes under. There we go. Okay, so now moving on to example 2. Okay. So in an ellipse, sound or light coming from one focus is reflected to the other focus. In a whispering gallery, a person can hear another person whisper from across the room if the two people are standing at the foci. So basically what it means is if there's a room that's like this, if the two people are standing at the foci, even if they're whispering, they can hear each other. Okay? So the Whispering Gallery at the Museum of Science and Industry in Chicago has an elliptical cross-section that is 13 feet 6 inches by 47 feet 4 inches. So what that means is that here, this distance, the whole thing from here to here is the long one, 47 feet 4 inches, right? And the distance here to here is the short one, the minor axis, 13 feet 6 inches. Okay. We want to write an equation to model this ellipse. Assume that the center is at the origin, so it's just the x squared, y squared, and it tells us the major axis is horizontal, so it'll be this way. Okay. So that means A here will go under x. Okay. So what we're going to do is figure out where the halfway is. Okay. So if the length of the major axis is 2a, so 2a equals 47 feet 4 inches. So there's 12 inches in a foot. Okay. So 4 inches, 4 over 12 is 1/3, so this would be 1/3. So then 2a equals 47 times 3 is 141 plus 1 is 142, so this is 142 over 3. Then multiply by 1/2 or divide by 2, same thing. Okay. This will give me 142 over 6, okay, which simplifies to 71 over 3. Okay. So this gives me the length of the major axis. Okay, from here to here is A. Okay. Then to find B, that's 13 feet 6 inches, so 6 over 12, that's 1/2. So that means 2B equals 13 times 2 is 26, so this will be 27 halves. Okay, getting B by itself times 1/2 times 1/2. This will give me 27 fourths. Okay. Then, now that I have A and B and the major axis is horizontal, A is going to go under x. So x squared over 71 over 3 squared plus y squared over 27 over 4 squared equals 1. Okay. And then it's just going to make it even messier, so we're just going to leave it like this. There you go. Okay. So now we want to know how far apart are the points at which two people should stand to hear each other whisper. Right. So this was A, this was B, and what we want here to here then is C. Right. So using our formula, c squared equals a squared minus b squared, we're going to find what c is, and then we're going to double it to get how far they are apart from each other. Okay. So c squared equals 71 over 3 squared minus 27 over 4 squared. Okay. Okay, 71 over 3 squared gives me 5041 over 9 minus 27 over 4 squared gives me 729 over 16. Okay. I'm just going to square root those and enter that into the calculator rather than anymore. 729 over 16. So I'm going to do the square root of 5041 over 9 minus 729 over 16. Okay. And then this gives me approximately 22.683736 blah 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 blah. Okay, so then I want to double it, so then I'm going to double it 2 times c, so times 2. Okay. And this gives me approximately 45.37 feet. So this is 3/10, so that's close to 45 feet and 4 inches, a third. Either way is acceptable. There you go. Okay, so why don't you try CYP 2A and 2B, and then come check your answer when you're done. Okay, for 2a, you should have gotten x squared over 2.5 squared plus y squared over 2.25 squared equals 1. And for 2b, how far apart are the two foci? They are about 2.1794 feet apart. Okay? If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so this elliptical is this elliptical, sorry, I should say pool table, not cool table, with only one pocket that is located on one of the foci. Boop. Okay, if the ball is placed on the other focus, boop, and shot off any edge, whether it's here, here, wherever, it will drop into the pocket. Okay, the pool table has axes that are 4 feet 6 inches and 5 feet. Okay, so the longer one is going to be the major axis, of course, so that's why it's here, and then the shorter one is going to be the minor axis. Okay, so write an equation to model this ellipse. We're going to assume that the center is at the origin, so that's why you still see it just says x squared and y squared here. And the major axis is horizontal, which means that it's going to be this way, and so A is going to be under x. Okay? So then solving for A, so this whole thing is all the way here, so from here to the center is A, here to the here is A, so that's a total of 2A, so 2A equals 5, solve for A is 5/2 or 2.4, so that's what, 2.5. Okay. Then to find B, it's the opposite, 4 feet 6 inches is 4.5 feet, or 9/2, and then divided by 2, that gives me 9/4, or 2.25, and that's why you see that here in B. How far apart are the two foci? So c squared equals a squared minus b squared. This is what a squared is. This is what b squared is. Subtract that, you get this. Get rid of the square by square rooting it. So that's the distance from your center to one foci. But we want to know how far apart it is from each other. So here to the center and then center to here. So that'll be 2 of that distance. So 2 times that will give me 2.1794. And there you go. Okay, moving on to now graphing them. Okay. So here it says find the coordinates of the center and the foci and the lengths of the major axis and minor axis of the ellipse with equation x squared over 16 plus y squared over 4 equals 1. Okay, so center is just going to be at 0, 0 because it's not x minus something, y minus something, so center's here. Okay. So this is a squared, so that means a equals 4. So that means the major axis is going to be 2a, so major axis has a length of 8. Okay, because double that. Okay. Here, this is b squared. Okay. I know that because 16 is bigger than 4, so that's why. Okay, so b here would then be 2, because square root of 4 is 2. So minor axis is double that. So minor axis is 4. That's the length of it. Okay. Then to find the foci, then right, and again A is underneath x, so I know it's going to be shaped this way, which means the foci will be here and here. So I will be adding it to the x value. It's this way. So I need to find what c is. So c squared is a squared, which is 16, minus b squared, which is 4. Okay. So that means c squared is 12, and so c is square root of 12, which is 2 square root of 3, right? Because 12 is 4 times 3, that square root of 4 exits as a 2. So here, my foci then will be plus or minus, doing the x, so here's the 0, plus or minus 2 square root of 3, comma 0, also known as plus or minus 2 square root of 3 over 0. And if you want approximately where that is, so that way it's easier to graph, that will be plus or minus, essentially, 3.5, comma 0. Close enough. Approximately. Okay. So first, how I'm graphing, I start at the center. So in this case, center is 0, 0. Okay. Then I go major axis, it's 4. So I'm going to go 4 away, 1, 2, 3, 4. 4 away, 1, 2, 3, 4. Then minor axis is 2 away, so then 1, 2. That's for the y, right? Underneath the y. So then 1, 2. Okay. And then I just need to connect it. Should be kind of ovally as best as I can. There you go. And then the foci, which I found is around 3.5. 1, 2, 3. So here and here. And there you go. Okay. So why don't you try CYP3, and then once you're done, come check the answer. Okay, you should have gotten something like this. Your center is at 0, 0. And then here, I know it's going to be horizontal because 49 is bigger than 36 and 49 is underneath the x, so I know it's going to be this way. Okay, so this will be a squared, this is b squared, so square root of that will give me a, so 7. So major axis then will be 14 across. Then if this is b squared, that means b is 6, and then minor axis is 12. Okay. To find where the foci is, okay, foci would be here and here, right? And so that's going to affect the x, right? So that's why it changes the x value from my center. Okay, so that's why I'm adding it to the x of my center. Okay, but it's a squared minus b squared. C squared is a squared minus b squared. So 49 minus 36 is 13, square root of 13. So adding that to my x, that's approximately 3.6. So that's here. Okay, so now we're moving on to our last example. Okay. So here we're going to find the coordinates of all the stuff and the lengths of things, and then we're going to graph it. Okay. So here, what I'm going to do first is I'm going to change it into standard form. So I'm going to group my x's and my y's. So x squared plus 4x, right? And then group my y's plus 4y squared minus 24y, and move my constant to the other side. Okay? Equals. For now. Okay, then I'm going to try completing the square. Okay, so here I note that this a value is still not 1. Okay, so what I'm going to do is I'm going to factor it from the y group. So this will be y squared minus 6y equals -24. Right, so I grouped my x's, grouped my y's, and then here it needs to be a coefficient of 1, so I'm going to factor out this 4. Okay. Then I'm going to complete the square. So this would be plus 4. Balance it on the other side of the equal sign, so plus 4. Okay. On this side here, -6 divided by 2 is -3. Square that is 9. However, this is really a 4y squared minus 24y, so 4 times 9 is 36. I really added a 36 on this side, so I need to add a 36 on the other side to balance it. Okay? Then I'm gonna do factor, so x plus 2 squared plus this will be y minus 3 squared. Okay? And then -24 plus 4 plus 36 gives me 16. Okay? We're not done yet though. Okay, so remember on this side it should be equal to 1. So to get this to equal to 1, I'm going to divide by 16 here. Divide by 16. Okay? So this here then will be x plus 2 squared divided by 16. This 4 divided by 16 is 1/4. So no need to write the 1 here. So y minus 3. 1 times y minus 3 squared is still y minus 3. And then this would be 4 equals 1. Okay? So now I can find things. Okay? I think I'm going to write it in a different color so it's easier to see. Okay? So center now is going to be -2, 3, right? Opposite side. So center, -2, 3. Okay? So this is a squared, this is b squared. So if this is a squared, that means a equals 4, which means my major axis is going to be 8. If this is b squared, that means b equals 2. So my minor axis will be double that, which will be 4. Okay. Now all I'm missing is my foci. Okay. So since A is underneath x, your foci is going to affect x. Right? So it's going to take whatever your x is here. It's going to be -2, and it's going to be plus or minus whatever that foci number is here. Okay. So again, that's c squared equals a squared. So 16 minus b squared, 4. Okay. We did that up here, everything. So basically, c is 2 square root of 3. So then -2 plus or minus 2 square root of 3, and then the y is going to stay the same. Okay. So we'll figure out what point this is in a little bit. Okay. So starting with our center is at -2, 3. So -2, 1, 2, 3 is here. Okay. With A, 4. Okay. And again, it's under x, so it's going to affect x left and right. So I'm going to go right 4, 1, 2, 3, 4. Left 4, 1, 2, 3, 4. Okay. B here is under y, so it's going to affect y, that's up and down. So this will be up 2, 1, 2, down 2, 1, 2. And then I can connect. Okay. Then my foci is going to be somewhere here. Okay. So I just need to know what -2 plus 2 square root of 2 is. Square root of 3. So then this gives me, which is about 1.5 comma 3. And then the other one will be the minus version. So -2 minus 2 square root of 3. And that will be about -5.4. -5.5. 3. Okay. So that will be here and here, and there's my foci. Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, so your equation should have been x plus 4 squared over 6 plus y minus 1 squared over 1 equals 1. So that means your center is at -4, 1. Okay. This is a squared, this is b because 6 is bigger than 1. So then if this is a squared, that means a is square root of 6. So your major axis is 2 square root of 6. If this is b squared, that means b is 1. So your minor axis is twice that, so 2. Okay. Then to find your foci, which is c, you use the equation c squared equals a squared minus b squared. So c squared equals 6 minus 1, which is 5. Square root of that is square root of 5. And so here, since a is underneath your x, it's going to be this way. It's going to be horizontal. So your foci will also affect your x. And so that's why you see this 5 is being added to the x here. Okay. And then I just found approximately where it was, so that way it makes it easier to graph. Okay. So started with the center at -4, 1. Okay. And then square root of 6 is about 2.4 away, so I went 2.4 away this way, 2.4 away this way. B is 1, so then I went up 1, down 1. Okay. And then the foci, I got these points, so then it's really close to here and here, the endpoints of your major axis, so it's a little bit hard to see. It almost looks the same. Okay. But that's it. There's your ellipse. Have a great rest of the day. Bye, guys.